So today we will discuss the implementation of a stack to convert an infix expression to postfix one. As we discussed in the earlier class, that postfix, to know what is postfix expression, how we can implement, right? Means what our processor does, that job we will be doing using codes, right? Because on computer or processor doesn't process an infix expression directly. Rather, it first converts the infix expression to postfix or prefix. Most of the cases generally it converts into postfix expression, then it evaluates its postfix form to get the result. Okay. So that we have to uh, learn how we can implement, and to do this we have to use the stack what you have completed, right? Mainly the operations, two operations, push and pop operations. So from yesterday's note here, I think I have given you the notes in your classroom, no? Hello, you got this
Yes,
note?
sir.
Yes,
Seen
sir.
it.
Hmm.
Yes, sir.
So here, see, these are some examples from INFIX, the how we convert the postfix, means how the computer or the processor converts into postfix or prefix notation. Right? Here you can see is very important one thing, that to parse any arithmetic expression, we need to take care of operator precedence and associativity also, because we know that while calculating an expression, we always take care of operators which has the highest precedence, which has the greater precedence, okay, and associativity. So we take care of this, right? So let us first discuss the algorithm how to convert an input expression to postfix one, right? Today, after discussing this algorithm, we will be showing the code. Okay? So you have to understand the code. It's not necessary that in a single class you have to understand. I will start discussing the code. I will start explaining the code. But still, if you have any difficulty, then we will discuss. We may discuss again, right? So, because there is a time constraint, you know. Hmm? Anyways, so let me tell you verbally, right? So this is our infix expression. For example, we have taken this expression. Okay. Now our job is to convert it into postfix. Oh, it's not. I think I didn't share my screen, right? Okay, let me share my screen. Present now. Yeah, the screen is visible.
Yes, sir.
Yes, sir. Visible.
Hmm. So now
Yes, sir.
let us discuss this conversion algorithm verbally. So this is our infix expression, for example, and we will try to convert it into postfix one. How to convert it? First, always we have to scan. We have to scan the entire expression from left to right. Okay. So while scanning, we have to stop at times. You have to stop at the end. How to determine the end? We will be taking this input expression in a string form, and you know that end of character is denoted by the null character in string. While you started string, you know that, right? So we have to scan the entire expression from left to right until and unless we reach the null value, right? Means string length. If we check if we come to know about the string length, then we know that how many elements are there. So we will limit our scanning just from the number of characters, right? So we have to scan the elements from the left to right. And you know that while scanning, we have to check the symbol which is being encountered is operator or operand. Operator or operand, right? If it's operand, we will simply push we'll simply add it to our postfix notation, which we are uh, which we are we are generating, right? So if we encounter an operand, we will just store it into our postfix form. Okay. Then see, we're getting a symbol which is not an operand, it's an operator, right? Then we have to check, see, we have to take the help of a stack. Okay. And while we encounter a star, we have to add it, we have to push that operator in a stack. Let's say it is our stack. Okay. Then this we got a symbol which is neither operator nor operand. It's in brackets. So we have to put a condition whether we encounter a bracket. And then we have to check whether this is the opening bracket or the closing bracket. If opening bracket is there, we will simply push it in a stack. We'll simply push it in a stack. Then we got another operand. We will simply add it to our postfix array. Yes, here will be dealing with array, isn't it? Then again, after B, we got another symbol which is an operator. So when we will be getting an operator, always we have to check whether the current stack, which is at the top most position. Here, the topmost position, in the topmost position, we have a bracket, opening bracket here, right? And always you know that the opening bracket, always when we got an this closing bracket, we will keep on removing the operators from that stack. Anyway, so we have not encountered yet the closing bracket. So here we have encountered a plus operator. So now we have to, what we will do? We will add it to the stack or we will add it in the post form. See, when we will be getting an operator, we have to check the stack whether the current operator has the highest precedence in comparison to the operators which are there in the stack, right? See, first the topmost element will be compared with this class cell, right? If it is this has the lowest precedence, this has the lowest precedence, right? So what we will do, we will simply, if we get this, we will simply pop it out, and here we will, no, not pop it out, we will see this has the lowest precedence than this, so we will be adding this one here, because plus has the greater precedence. Always, if we get the operator which has the greater precedence, we will keep it in the stack. Now, second, we got another operand C. We will simply, what we'll do, what we will simply add it to the here C, right? Now we are getting another symbol which is the which has the highest precedence. Means always we discussed in the last class, we will process the expression or sub expression which is there in a bracket here. So where this bracket close, here the bracket close. So that the moment we will encounter a closing bracket, we will keep on removing the operator from the stack, and we will stop when we will get an opening bracket corresponding to this closing one, right? So here we will keep on removing. To remove, what we have to do, we have got here the topmost element is plus, so we will be simply popping that operator and simply add it here. This is plus, right? Then again, now the topmost element is this. Here we will stop removing and we will just remove this one. So first we have removed this one, then we have removed this one, because this is the opening bracket corresponding to the closing bracket we just encountered. So we have to remove this one, right? And here next element, there is no element, so we have reached to the end. So when we'll reach to the end, you will remove all the elements left in the stack, okay, and add it to the POSTFIX one. So this is our star, right? You can see just what we learned in the last day. First, this sub expression will be processed. So for POSTFIX, we will get BC plus, then BC plus. Step by step, we say that next step, I will write A star, then BC plus, BC plus, and put an underline just to make the examiner understand that this is a single token and this is another token, right? This is another token. Got it? Okay. Now this is,
Yes, sir.
now we have to perform within this token. So the next step will be this one, this one, this one. Next step would be this, what? A, B, C plus and stuff. So according to our algorithm, what we got this one. Okay. So now what a algorithm I have explained, now I will show you how to write code maintaining this algorithm. Your job will be whatever I have discussed, you have to write the algorithm step by step. Don't copy from any other source. Whatever I have just discussed, you have to write the algorithm step by step. Okay. What we do actually, first we develop an algorithm. What we do, we just develop an algorithm, and following that algorithm, following that logic, we encode, we codify it, right? We write the program for that. So today I will show you the program about this algorithm. Only you have to do, you have to write the algorithm and submit, right? Fine. Okay. Hello.
Okay, sir.
Hmm.
Okay, sir.
Now let us discuss about the coding. Slowly I will be explaining each and every statement. If you can't understand from today's class, in the next class also we will be discussing this again. Okay, so let us start. Hmm. You know that always what I told you, whatever structure. See, while studying structure, you have noticed that always I used to define the structure globally before main, right? Because all the functions have the privilege to access that definition, to access that structure, right? So that's why the better convention is always we prefer to define the structure globally before the main. So here and the array what we will be taking. Say this is our stack. We have defined a stack first. Character means it's a string, right? Because we have defined an array of 25 characters. What? Why? Because we will be supplying a string. This will be treated as a string. If you say if you write this one, if you supply ultimately you supply these two star sorry, two uh, two star, let's say 3 plus 5. It's an integer expression, but still the computer will take it as a string, right? After that, it will convert the entire string infix expression into postfix expression. That will also be a form of string, right? Isn't it? Because whatever characters, these are also the characters, no? So whatever will be supplying from the keyboard, that will be taken as character. So these enter string, this enter or this all the characters we have to put in a single string. Got it? So this is our string. So we have to take a string first. Okay, string of 25 characters. You know that. I think you have done it. Initially, when there is no element in the stack, the top element, the top index will have the value -1. Okay, in the last class also we discussed this one. Now, or whatever we'll be doing, push and pop, this is the operations. I think you all this push and pop operation you have done today, isn't it? In the lab? Hmm?
Yes, sir.
Yes. So when
Yes, sir.
what we are doing first, that pre-incrementation, we have to increment the value of top first. Then after the value is being implemented, that in that location we have to push the element. We have to store the element that is stack, right? And that element we are pushing here. So always we are doing it. And while popping, what we have to do? We have to first decrement. We have to first access the element, return stack top. We have to access the element in the current in the from the position where the top is pointed currently, right? After that we have to decrement the value of top. That's why it is post decrementation. Got it? Hello, yeah,
Yes, sir.
today.
Yes, sir.
Okay. Now let me discuss first. Let me show you the main. This is our main function. Only this few number of statements are there. Because I told you in data structure, whatever we will be doing, we have to define a function for each and every sub operations. Okay. So main will should not contain so many should not be lengthy, right? So main only contains this many statements. Here, what we are doing, we have taken an array means string of 25 characters where our input expression will be stored. Let's say I have taken an example. You can also use a getAce to take the string, to take the input, to take the input expression from the user also. Okay. To make you understand, I have taken an example. That's okay. It's been constant. Okay. So you can use getAce to be interactive with the user. And after this expression being converted, we will be storing that converted expression into POSTFIX. So of postfix will must be of same number of characters, 25, right? Okay, it maximum it may be 25, but it may be less than that, because here the postfix expression, I don't know whether you have noticed it or not, the postfix expression you will not get any bracket. See, postfix or prefix, you will not get any bracket, because the brackets are removed according to the algorithm, isn't it? Just now what I told you, that while when we'll be getting encountering in bracket, we will scan up to the bracket, the opening bracket, and we are just removing that bracket from the stack. Okay, so your brackets are not accepted in postfix and prefix expression. Okay, means the form, the expression which is processed by the processor should not contain any bracket. Okay, this is a simplified or reduction form, reduced form. Anyways, so let us discuss this one. So we have taken another this one. Now the entire job we have kept in a single function what we have defined. These are all the user defined functions. You will not get any ready-made function available in the uh, C library. Okay, so this is our own function. We will discuss this function, how we have defined this. So this is our infix. The function will take the infix one and it convert the infix expression to postfix one, and ultimately the postfix array will contain the postfix form. Now here we are displaying these two expressions, infix expression infix and postfix expression postfix, right? Percentage, or you can also use the puts function, right, to display any string. Got it? Okay. This up to this clear to all of you?
Yes, sir.
Because
Yes, sir. Clear.
I have not started discussing. I am just showing you the main part. Now we will be discussing. So first, the control encounters control gets this expression, right? This statement, it will start processing. So it will be called. This function is called the moment control executes this one. This function will be called, and control will go directly to that function. This way, step by step, we have to understand to convert. Now convert. Here I have defined the convert operation. Now convert operation, convert this function taking these two array in string here. So this is these two strings infix and postfix, which will be char or of char, right? Now we have taken this many variables, I symbol j, and we have initialized with j. And stack plus plus stop. What happened that uh, we have kept a symbol, a special symbol, where this removing the elements from the stack will be stopped. We have to limit. We have to stop copying the elements from the stack. So when we will come to know that all the elements or all the operators have been removed from the stack, so we have to limit this popping from the stack. We have pushed a special symbol which will not be there in our infix. So this special symbol we have pushed at first. This is a special symbol, right? Character symbol. Means when we will be getting this one, we will come to know that processing has been completed, right? We processed all the operators from the stack. And one thing you may notice that here, while converting this one, we are actually handling one stack. This stack doesn't contain any this stack doesn't contain any operands. It must contain only operators, right? Why we are taking this? Because whenever we will be getting an operator, we cannot claim that this operator will be processed, because before that we have to check whether any operator of highest precedence are left in the stack. So we have to process that one, isn't it? We cannot here if bracket, if bracket is not there, if we cannot process it plus, right? Before processing plus, we have to process this star. The moment we are getting this one, an operator, we cannot be sure that this operator currently encountered will be processed first. We have to check any other operator which has highest precedence, comparing with this one, is left in the stack or not. If it is left, then we have to process that operator first. So multiplication will be done first, then addition, isn't it? So always we have to check the stack, the status of the stack, whether any operator compared with the current operator is has precedence or not. Okay, so that's why we have to take the help of a stack which will contain the operators only, and stack always will contain the operators according to the precedence from top to bottom. The topmost elements will be having always highest precedence from the lower ones. Okay, so this way the stack will get an descending order according to the priority of the precedence from top to bottom. Got it? Means while pushing the elements, we will be maintaining that one. Okay, so this is what we are explaining. Well, this one. So convert expression. First, what we are doing, after this is done, we are scanning, means we are retrieving each and every character from the, from the stack, from the input expression. So string length strlen, you know that how many characters are there in fix, that we come to know from the strlen. So we have to scan up to that number of elements, right? So this is actually for scanning the entire infix expression. Got it? Now while scanning, we are, whatever we are encountering, either it may be in operator or operand, whatever it is, we are storing it in a different variable called symbol. Got it? The symbol first I is 0 symbol in fix I. Okay. Once there, for example, symbol is this A. Got it? Now we have to check it is an operator or operand. Here A is not operator, right? A is an operand. So we have to check the symbol which is encountered is operator or operand. Got it? Okay. So if it is, if it is not an operator, then we will be just we will not store it in a stack. So this is operator symbol is another function what we have defined here. Is operator. So how many operators, mathematical operators will be there? Plus, minus, star, multiplication, division, expansion, and these also we will, though it is not an operator in that way mathematically, but still we will be putting it in our symbol, in our operator list to for our program. Okay, so these two brackets are also considered as an operator. Okay, so if any one of these is becomes true, our function will return 1. Otherwise, if any operand we encounter is checked, then it will return 0. Default return 0. Okay, the default case return 0. Okay, got it. So you know this is an example of switch case. Here also you can see that we have used that switch case feature what we learned in the CS201. Could you remember this one, Santon?
Yes, sir.
Sir, after every case statement we can use break, or ultimately after here it is
This is
break
this is
after.
this is a common uh, conclusion, na? Return one. That's why he didn't write it separately. If each and every case has some another implication, has different implications, then we will be writing, we'll be putting different statement in different cases. Here, for all these, the result will be same return one. That's why we have taken it as common. Got it?
Okay, sir. Okay.
Hmm.
Okay.
Our purpose is to check whether this is operator or operand. So these are the operator list for any one of for any cases within this among this list. This return will get return one will be returned, otherwise it will be 0. Right now we will be checking
Yes, sir.
operator return 1 or 0. If it returned 1, then we are sure that this is an operator. Otherwise, we can be sure that this is not an operator, this is an operand. Got it? Okay. So we are checking this is an operator or not. If it is not an operator. It is not operator means operator will return is operator will return 0, right? If it is not an operator, is operator will return 0. Okay, according to our function. So here we have checked is operator. If is operator 0, so you show that this is not an operator, this is an operand. So what we are doing according to our example, you will be just storing this is an operand. So we'll be just storing in our postfix what we are generating, postfix array. Got it? Okay. So that what we have done it here. In our postfix
Okay, sir.
is symbol, and J++ always after pushing on element we have to go for another one, go for the next position where the next element will be pushed in the stack. So J++J is taking care of it, right? Postfix J. Now else, let me else. Else means if it is an operator, then means any operator we may encounter according to our example, means in any case according to the INFIX expression to be supplied by the user, we can get any operator. This may be opening bracket, this may be closing bracket, right? So if it is an opening bracket, what we did, see here, we got an opening bracket. So what we did, we just what we did, we push it in the stack. Just now I discussed now. Here we encountered first one, so this is star. So whenever we will be getting an opening bracket, we will just push it on the stack. So we have just pushed it on the stack. We have just pushed it on the stack. Push symbol. Push this one. Now else we have to check whether it is a closing bracket. If closing bracket is encountered, what we did? We just kept on removing all the elements after when we encountered this one. I told you, I just explained that we have to keep on removing all the operators from the stack, and we have to add it to the postfix one, right? Until we get an opening bracket corresponding the closing one we get in our stack, right? So that what we have done it. After getting this one, what we have, we keep on removing all the elements from the stack until we get an opening bracket. So stack top until we get opening bracket. While this here, this is a loop. if we get an closing bracket, we have to keep on removing all the elements from the stack until we reach an opening bracket in the stack. So while stack top not equal to opening bracket, right? We have to keep on removing the elements from the stack. And how to remove an element from the stack? Pop function will take care of it, right? And pop, so the elements we are getting from the pop function, we will be adding it to our postfix one. Just now what I told you, na, when we will be getting an closing bracket, we have to keep on removing all the elements from the stack, right? Only all elements, these all the elements will be of operator, not operands, and these operators we be will be storing in our postfix operation until we get an opening bracket corresponding to this closing bracket. So this we have done it. So we are removing, we are popping the elements, and that element we are adding it to our postfix operation, postfix form, and J takes care of it, right? Postfix is another string. We are going to store our result, and J plus plus. So this loop will be continued till this opening bracket we get in our stack, right? And after that, what we told, that after getting this opening bracket, we will also remove this opening bracket from the stack, right? Got it? Hello,
Yes, sir.
Yes, sir. Got
are you
it.
understanding?
Yes, sir.
Yes, sir.
So actually our stack was this, na? Actually, let me first rewrite our stack. This, then class, this was our status of stack for this, right? After this we got this one, na? So when we got this one, we will, what we will be doing, let me regenerate our postfix server. Okay. What we will be doing, that first A, B, C plus ultimately this, but step by step, let me explain. This step is this plus, we got it start and add this. Okay, so when we will get this one, we will be removing all the elements from the stack. We are removing the element from the stack, and we are just storing it here. Intermediate step of the postfix one, right? This is a step by step the presentation of the generation of the ultimate postfix form, right? So this is, here we have added it this here, this plus this operator here with the BC, and we will stop when we'll be getting this one, and this is also removed from the stack. This is what is explained in the code. We have to pop out this opening bracket also. Now else means corresponding of this if else, it is not an open closing bracket. Then we have to check whether the operator we are encountering is what? Plus, minus, means this many operators. Apart from these two, these four cases may be there: plus, minus, star, division, expansion. So for this we have to check what we have encountered, and whatever operator we have encountered, we have to check the precedence of this one also, right? The operator which is currently encountered has the highest precedence or lowest precedence than the operator which is there on the stack at the topmost position. If it is less, what we will be doing? If it is less, what we will be doing? We will be removing the operators. We will keep on removing the operators from the stack until we get an operator which has the precedence lower than this. Got it? What we are doing, while precedence of the current operator we encountered is less than equal of the precedence of the operator which is there in the stack. Okay, so when it will be stopped, when this will be just opposite, when the precedence will be greater, precedence of the symbol currently encountered becomes greater than this precedences, this precedence of the operator which are there in the stack, right? So we have to keep on removing the elements from the stack, and that operators we will be adding on the postfix one, J++. Okay, and at times we will be getting an operator which has highest precedence uh, than the topmost operator in the stack, and we have to push that element also on the stack, right? What we did here, what we did actually, let me explain this one again. What I did first, let me delete all this one. I repeat this stages. Okay, delete this. Sorry, delete. This is our stack. Got it? First, we are getting an element, that is symbol, which is operand. So we will just storing it in our postfix form. And before that, we pushed at very first, what we did, we put a special symbol in the stack. Okay? Then we are getting this operator. So this
হ্যালো
operator.
স্যার, স্যার
Hmm.
বলছি পোস্ট অ্যান্ড স্ট্যাক এটা কি স্যার?
Post, or this is the stack. These two are the arrays basically. This is also an array, and this array holds the results. That is, we are actually our aim is to convert this infix form to postfix one. So where we will put it in the postfix result? Postfix an array, na? An array. These are array, and stack is also array. You know, isn't it? Isn't it or not?
Yes sir.
Stack is also array. So ultimately,
Yes,
these are arrays. Okay, so you are taking the help of arrays to do this. That's why I told you that here stack will be used as a tool for this algorithm, which will convert an infix expression to postfix one. So here, if we get then operand, we will be storing in postfix array, and if we get an operator, we will be storing it in stack array. Okay, so now we got this one star. So we will be just pushing this one because no other element other than is present. So we don't need to compare it again. So we'll be just pushing this one. Now we got this another symbol, which is a opening bracket. So when we are getting the opening bracket, we are just here in this example. When we are getting this opening bracket, we are just pushing that symbol here. So we will be pushing this opening bracket here in the stack. Okay, got it? Now again this symbol has been encountered. So we will be just adding this symbol here. If we get operand, we will be simply adding it to our postfix form, postfix array. Now again, now got it. We got this one. The moment we are getting this one, what we will be doing? We will be checking the precedence of this comparing the precedence of the topmost element. So this has a lowest precedence always. Okay, so this is the highest precedence, so we can put it here. I told you that according to the precedence, always the topmost element will be having the highest precedence. So this has the highest precedence than this opening bracket, right? Then we got this one, C. Will be pushing this simply C here. Got it? Now we got this one. So the moment we will be getting this closing bracket, what we did, the moment we got this, if this, we will be keep on removing the elements from the stack until and unless we get an opening bracket, and after that, after removing all the elements up to this opening brackets, we will be remove the opening bracket also. So this is what we have, only one element is left, so we will be remove this element from this stack and we will be simply adding here. Again, no operator, then this opening bracket has reached, so we'll be just removing this one. We will not push this opening bracket here, right? This is what we have done here. We just popped out this element because ultimately this has been reached. Nah? This condition is showing this one. Eventually, the will be reaching where this means opening bracket. Okay. Else means the bracket what we are talking about. This precedent, this operator talking about. I told you that always the highest precedence means the symbols of the operators of highest precedence will be stored in the stack, right? So this is taking care of this piece of code. Else, this if it has the highest precedence, the symbol means that we are encountering, we have to simply push this one, right? Just now what we did in this case, because that star, that this plus had the highest precedence the compared than this, that's why we push it here, na? We push it this plus. Plus has the highest precedence than the opening bracket. That's why we pushed it. Okay. So this is my expression is very short expression. It will be clear for you means vividly in a very more clear sense if we take a large expression that we will be also discussing later on. So let us concentrate on a short expression first, okay, to understand it initially, to understand the code. Okay, so this is what we are doing, and ultimately when we will be getting a symbol which is that has the greater precedence, we will be pushing this one, pushing into the array. Okay, and this way this way after the for loop is completed, all this checking is done. What we will be doing? We will be checking whether any operator is left on the stack or not, and whether we have reached to this special symbol. So we have to always, what we will do, we will be popping all the elements from the stack and we will be adding all the elements in the postfix array. Okay. Ultimately, we have to terminate that postfix expression putting a null character. This null character terminates the string which we have converted, right? Let me execute this program again. See, we can see INFIX expression is, what was our expression? 1 star 2 plus 3. So what we have done, 2 3 plus star. That is what we just written, isn't it? If it is 1 star 2 plus 3, what will be the postfix form? This one, na? This one will be our what? 1 2 3 plus star. This is what we got, na? 1 2 3 plus star. Got it? Hello.
Yes, sir.
How many of you
Yes, sir.
understood? Because this is a big program, I think, for the first time you are facing, right? So you have to, I will be giving you the material. You have to understand the code, each and every statement of code. Then again, I will explain. If you have any difficulty, you will feel free to to uh, let me know whether you have understood the entire code or not. If not, then I will not mind to explain the code once again in the next class. Okay. So anyone want to say anything?
স্যার
Hmm. Bol.
বলছি যে আউটপুটটা কি কিরকম আসতে পারে ওটার আউটপুটটা প্রোগ্রামিং এর
দেখিয়ে দিলাম তো।
বুঝতে পারলাম না ওটা ঠিক।
Did you understand this one? এটা বুঝতে পেরেছিস?
হ্যাঁ, অ্যালগোটা কিছুটা বুঝতে পেরেছি, কিছুটা পারিনি।
আউটপুটটা কিরকম আসতে পারে মানে আউটপুট will come according to the algorithm. Here you followed this material. How it is coming? Got it? In just now I explained this one. How we are generating this one. না?
এইটা বুঝেছি।
তাহলে আউটপুট এটাই আসবে। তো কোশ্চেনটা ইজ মানে what will be the output we can expect. This is our output. We got it. The problem is you didn't understand the algorithm completely, isn't it? Or no?
Yes, sir.
So feel free to tell me now. This session is going to end, right? The next class also I will be giving you the material. It's bit not, I will say, not complex, right? It's bit, but you have to concentrate more to understand this one, right? Data structure is very easy if you understand the logic. If you don't understand the logic, then you will not be able to 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 be an expert person on this, right? Because you have to understand, you must understand these algorithms and how we are writing the codes. Otherwise, you will not be able to join in the software industry. Got it?
Okay, sir.
The next day we will discuss again. I think you have today we have started writing code for push and pop operation, right? So you concentrate on that push and pop operation. If anyone is left to understand this push and pop operation means in C, this code, if you don't understand the code, I will discuss the code for push and pop operation again. Then because we are here, we are using this stack as a tool for this algorithm. So the prerequisite that you must understand the push and pop operation of the stack clearly. Okay, otherwise you won't. How will you use the stack, right? First you have to know how to maintain a stack. Got it?
Okay,
So
sir.
in today's session, in the next class, we will discuss according to your requirement. My point is that up to this discussion, up to this point, everyone has to be confident enough that you have understood. You all have understood, right? Fine. Okay. Thank you.
Okay, sir.
Okay, sir.
Thank you, sir.
Hmm.
Thank you, sir.
Hmm.
Thank you, sir.
Hmm. Welcome.